All right, so what we're going to do for a minute is we're going to play what I call kindergarten calculator. Okay, I have to do this every year. It's not just this year because it's online stuff. Happens every year. So grab your scientific calculator. Now, I don't care if you have a calculator like this or if you have a graphing calculator. It doesn't matter. What I want you to do is, the first thing I want you to do on your calculator is I want you to find this button, EE or EXP, or there's a few of you in the room that might have times 10 to the some power. Find that on your calculator. Okay? For yours, because I know that calculator, it's the times 10 to the n, and I'm going to show you something about yours to get the right answer every time. Find your calculator. Now, here's the deal. If you're using a calculator on your cell phone, first day of this class, first video of this class, one of your supplies is a calculator. And we're at week 3. Halfway through week 3, you should have already had a calculator. You need to go get a calculator. You cannot use your cell phone. Okay? Now, for your calculator I'm going to use has the EXP. Now, we're going to play kindergarten calculator for a minute because if you use some of the functions you've done in the past, you're going to find somehow I keep getting it wrong. This is why some of us were screwing it up on the quiz. So I'm going to fix all that right now. Here we go. Let me ask you a quick question of what you know basically of math. If I had that, what is 1 times 10 to the second really? Let me ask it like this. What's 10 squared? 100 times 1. So basically this is 100. Here's what you need to know. On your calculator that you have, this box right here is one of those keys. So on my calculator that has this button, I push 1, then I need this. So I push EXP, and then my calculator is waiting for me to type the power. I type 2 and hit equal, and it gives me 100. You try on your calculator. So I want you to type 1, find the button, put the power of 2 and hit equal. Your calculator should tell you 100. That's the correct way to do it. But Mr. Kelly, when I was in one of my other classes, they have me use the caret key. If you use the caret key, you know what I'm talking about? They have you type 1 times 10 caret 2. Some of the functions in this class later on, that caret key will make you be off by a power of 10, 100, or 1,000. It'll be wrong sometimes and right sometimes. If you do it like this, it'll be right every time. Okay, so I'm going to take out the caret. Can everybody get that? Stopping for a second, can everybody find one of these keys? I don't care that you know how my calculator works. You need to know how your calculator works. All right? Everybody okay? Don't, because I'm about to move further ahead with it. Now, so what if I had something like this? 4.832 times 10 to the second. Put that in your calculator, hit equal. 4.832 times 10 to the second. Again, you're using one of these buttons. You should get 483.2. 483.2. Can everybody get that? Now, you know this from math class, but when you multiply by a power of 2, it's going to move your decimal 2 places to the right. Now, that verifies with that pretty simple, but we're going to be using numbers that are much larger on a big, big scale or very, very, very small scale that you can't just see it on your screen. I'm going to show you in just a second. Everybody's okay with this? All right? Now, in this class, later in the year, we're going to use this number, 6.02 times 10 to the 23rd. And that's a huge number. Try that real quick. 6.02 EE or EXP 23 and hit equal. Nothing happens. And the reason nothing happens is there's not 23 spots on your screen. Are you with me? So in reality, what that means is I would take that decimal and go 23 places to the right. That number doesn't fit on the screen. But now that number's in my calculator, if I have to do math with it, my calculator can do it. But if I can't put it in my calculator right, then I can't do the math right. Stopping point. Does everybody understand what I'm talking about? It's not hard. You're just pushing buttons wrong. Now, somebody help me real quick. If this number right here was to the negative second power, what does that do? Decimal goes the other way. So if I put, now let's go ahead and put it in like this and make sure, but I should get an answer of 12.04832. 2. So put 4.832 times 10 to the negative second equals, and see if it gives you this. If you can get those numbers, then you're using your calculator correctly. For some of us on the quiz, you were using the caret key, or you were trying to push times 10 to the power, and you're like, how am I missing all these? This is easy. I'm just pushing multiply. And it's because you're using it wrong. Now, let me say these words. Every year for the 27 years I've been here, I have to do kindergarten calculator, because we're not used to using them like this. And I get it every year. So I want to make sure you have it. Big stopping points. Anybody have a problem with this? Because I'm about to apply using it. Everybody else? Okay? All right. So when we were doing problems like this on the quiz, when we were doing addition, so we're just going to use our calculator, and we're just going to do this simple question. We're going to take your calculator, 32.67 plus 4.3. Add them together. 36.97 is what should be on your calculator. Now, on the quiz, you can't put units, but centimeters and centimeters is centimeters. Okay, that's not a big deal. They just wanted you to put numbers in. Great. Is that the answer? No. In science, you have to have an exact answer. And following the rules that we did, I can see, especially if I line my numbers up right, that's the last place the numbers overlap. Remember that from the video? Perfect. Love this example. Okay, cut it off. Does that make that round? Yes. So the 7 makes that 9 round to a 10. So my answer is actually 37.0. And that's the answer I would have typed into the computer to get it right. Okay? But some people just put 37 and it was wrong, because it had to go one decimal place. Follow me? Addition and subtraction do the same thing. How many places after the decimal? 1, 2, 1. So my answer can only go 1. Subtract those numbers. Subtract those numbers. 28.37, is that right? Doing it quick by hand? Okay. Same rule. 2 places after the decimal, 1 after the decimal. My true answer on this one would be, or the correct answer is 28.4, because that makes it round. That would have been the answer I put in. I hope this is, you're seeing, oh, I see what I did. Okay, I do this every year. I teach it, and people are like, yeah, I got it. They do the worksheet and like, I had it. Okay, I really don't have it. This solves most of it. I have to let you fight through it. So pretty much the quiz online is not a real grade. It was a practice for tomorrow's test. So if I solve it today, you'll have way better grades tomorrow on the test. But that's why when some of you messaged me, which is fine, I want you to message me, I was sort of vague. I want you to fight through it because I knew it wasn't a grade. But now, does it make sense? Let me go back to the first one. You do not have to type this back in. If this would have had a 0, we'll just pretend that's the answer. It's not. Okay, but if I add these together, there's my answer. That's not where I stop it, is it? I would stop it out here, and this would be the full answer. Addition and subtraction follow those rules. Does everybody see what's happening? The one question that really kicked people was this one. It'll say something like 7.34 times 10 to the second plus 8.173 times 10 to the third. Add them. You know what I do on this one? Break it out. Doesn't 10 to the second mean move it 2 places? So in reality, isn't that 734? Move this one 3 places, 1, 2, 3. The answer is 8173. Let me make that a 2. Let me make that a 2. Here's why. 1, 2. 817.3. When I add those together, can you see where I'm going to have my decimal? No decimals, 1 decimal. My answer is going to have no decimals. There it is. So I just push the button. Boop, 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 boop. Write the answer down. Are you picking up what I'm laying down? By the way, I told you in the first video, I'm weird. I make weird sounds. Why? I don't know. It just comes out. Okay, do you see what I'm doing? Let's take those same numbers and change the rules. We're going to multiply. Take those 2 numbers and multiply. Take that line out. Okay, so there's our original numbers. 32.67 times 4.3. And I'm actually videotaping this so for my online students. So they're like, yeah, he's weird. He's making sounds even online. Why does he do that? I don't know. 140.481. Everybody okay with that? It would be centimeters times centimeters to centimeters square. We didn't put the units into the quiz, but that's what it would be. Is that my answer? The rules are different. You count sig figs. Help me out. How many sig figs in this number? 4. How many here? 2. The least. So I'm going to go 1, 2, and stop my number. A lot of people just put 140 point, and what a lot of people did on this question is they went 2 sig figs, 1, 2. No, that's decimal places. On sig figs, you start at the front of the number and then cut it off. Catch that? This solves a lot. I know. Got it. Okay, 1, 4, stop. Does the 0 make it round? No. Okay, so I got it. So my answer is 14. No. Now I'm going to pretend for a minute. I'm going to take the 1 out. If that's money, if I have $140.48, that's not $14. I have a hole in my number to get to the decimal. What do I put in the hole? Placeholder, which is a 0. Now, if I'm correct, how many sig figs in that? 2. The 0 is just a placeholder. How many did I need? 4 there, 2 there. I needed 2. So that's my answer. Do I put the decimal? This is what gets people. Okay? There's a big difference between 140, 140, and 140. Remember this from the video? If I put 140 with the decimal place, I'm saying that's exactly 140. If I put 140 with the line over, that's exactly 140. This is 140, but I'm not exactly sure of that. That's why that's just a placeholder. Unless you tell me something different, I'm a little unsure about that 0. Remember this from the videos? Okay? And so I have to be careful what I do. Okay? For some reason, people are counting sig figs wrong. So let me do this real quick. This is easy. Got it. Sandwich rule is easy, right? The question is these. Rule number 2, sandwich rule. So first rule was anybody that's not a 0, that's the 7, the 3, and the 1. Sandwich rule is rule number 2. That's easy. There was something on both sides. That's easy. Rule number 3, 0's at the end of the number and after the decimal. Those are after the decimal. Are they at the end of the number? No. So their job is what? Those are all placeholders. So I have 1, 2, 3, 4, 5. That's it. That's all there is to it. We'll make it a little too hard. The only one that's tricky see that number? To the 4th means go 4 places, right? 1, 2, and then what comes after the 3, 4? 2 zeros, right? What are the job of those zeros? Placeholders. This is the actual easiest question. Re. That's how many sig figs there are. Yes, I said re, not 3. Okay? So if I had 7.89 times 10 to the negative 17th power, I'm going to go 1 and then 16.789. Okay? Those are all placeholders. All I got to do is count right there. That's how many sig figs I have. Yes, ma'am. Like that?
Yeah, but like it's not directly after the decimal, it's like
That? Okay. Okay, got it. Okay. Okay, so let me do it like this. Rule number 1, got it. Rule number 2, do I have the sandwich rule? No, because there's nothing on the other end. Rule number 3, a 0 at the end of the number and at the end of the number and after the decimal. Those are all after the decimal, but that's the only one that's at the end of the number. So rule 3, got it. Now I have the sandwich rule. Do you see something on both sides? So then it automatically includes those. So when you walk through the rules, you don't have to actually go in order. See, rule 3 came in and then it automatically made the sandwich rule. That was a really good question. Thank you. Everybody in class okay? Now, when I add and subtract, just a reminder, add and subtract, I'm lining decimals up. When I'm multiplying and dividing, yeah, I got to do this. One more question. So when I multiplied these two, I got 140.481, 4 sig figs, 2 sig figs. 1, 2, cut it off, have a placeholder. Do I put the decimal?
No.
Nope, because that would make that exactly, and I don't want 3, I needed 2. Take these two numbers and flip them. I want you to take 4.3 divided by 32.67. Just using, and it doesn't matter what numbers I use, I'm just using these same numbers and goofing around with them. 0.13, oh, it actually on my calculator says 0.131619222. Yeah, that's not the answer. I mean, that's the answer on the calculator, but rounded. Okay, sig figs. How many? 2. 4, so my answer has 2. Start at the front of the number, that doesn't count. Why? Placeholder. 1, 2, stop. Does the 1 make it round? Nope, rest of the number is gone. Are we picking up what I'm laying down? We okay on that? Okay, so let's pretend here for a second. I'm gonna take this whole number back. I don't 161999222. I don't care what the answer is. Okay, so let's pretend that however I divided it out. Ooh, let's say that's the number. That's way wrong, but let's pretend. 2 sig figs, 4 sig figs. Got it. I'm gonna go 2. Doesn't count. Doesn't count. Doesn't count. Doesn't count. 1, 2, stop. Placeholders never count. See how I did that? So if it was 0 point, those are all placeholders. That's why it's so important that you know the rules first. Don't count, don't count. Okay, 1 real number, 2 real numbers. That's where I'm going to stop, and then the rest of the number's gone. Yes, ma'am.
So on something like that, if you have the 0 right before the decimal, the 0 is that.
It's a placeholder. Oh, if you don't put it or put it, it doesn't matter. Doesn't matter. Okay, so I did you a favor. Here's what I did. I went back into the quiz and I upped it to like 10 times. You do not have to do it 10 times. Now that you've got it, you can log into yesterday, do the quiz. Am I taking that quiz for a grade? I already told you. Am I taking it for a grade? No, I'm not. Go in, try the quiz real quick. See if you can get the numbers. There is one that's screwed up, okay? So if you're like, it's probably the one I screwed up. But everybody's getting different questions. It's a random quiz, okay? So you go through, you should be able to get an 80. If you're getting an 80 or above, you're awesome, okay? So I upped it. There's some people first period that said, I'd like to do it 2 or 3 times, try some questions. Okay, I'm ready for tomorrow's test. Today's on Canvas, all you're doing today is you're watching a video on the scientific method. It's easy. There's a fun video in there from the movie The Sandlot, the greatest movie ever made, okay? And so that's sort of fun. The only thing else I need to show you is this for tomorrow's test. And when I do it, you'll be like, oh, that's really easy. Watch this. Come on, pen. 4.835 centimeters to meters. Okay, but Mr. Kelly, how do I do railroad tracks and get the right answer? Watch this. It's easy. So if I'm setting my railroad tracks up, 4.835 centimeters railroad track. 100 centimeters is 1 meter. Got it. So I take my calculator, when I divide by 100, decimal backs up 2 spots, right? 0.04835 meters. But Mr. Kelly, this is multiplication and division. So I go on sig figs. Simply, how many sig figs are in this number? That's how many you put in your answer. And I'll show you why. So this has 4 sig figs, placeholder, 1, 2, 3, 4. That's the exact answer. But Mr. Kelly, why don't I use these? Let me explain, because it's easier if I saw you face to face and said this. These are called static numbers. Static. Why do you call it that? Simple. Let me take one you know. How many inches in a foot? 12. Can there ever be anything but 12? No, so that number's really set in stone. You can't change it, right? How many seconds in a minute? 60 seconds. Those numbers can't change. So you can't, numbers that can't change, you don't use for sig figs. So anytime you're doing a conversion, however many sig figs are here, that's what you put in your answer and you have it exactly right. Did you catch that? So if this would have been, 74 point, 1, 2, 3, 4, 5, you put 5 in your answer and that's the exact answer. The steps that you use to convert are all static numbers, meaning they can't change. Nanos, 1 times 10 to the 9th all the time. A mile is 5,280 feet. It can't be anything else. What a random number, right? Our American system is awesome. Somebody started walking and said, "Whoo, I got tired. How far did you go?" 5,280 feet. Ah, we'll call that a mile. Seems random, doesn't it? Have you ever wondered why an inch is 12 inches is 1 foot? Why 12? Why not 10 or 20? Easier numbers. It's 12. Why? I've been told that my whole life, right? That's why the American system is sort of screwed up. That's why in science, we use the metric system. Everything's in powers of 10. And so the numbers are a lot easier. So if you do a railroad track, whatever you start with is what you put in your answer. Okay? You can practice the quiz once or twice. I don't care. If you're like, I got this, I don't need it, you don't have to do it. The quiz is sitting there. Make sure that you watch the video for today. It's pretty simple. Everybody know what's going on? All right, you got it. You can get started.